Okay, so for a warm-up, we have a few factoring problems, but before we do those, I want to take a look at a slightly different problem where we actually work backwards. Hopefully, you have some recollection of your time in algebra on how to do these type of problems. But first, we're going to multiply these two together. What are some strategies that you learned to do multiplication, like a problem like this? Do you remember an acronym maybe you used? Distributing, some of you learned distributing, some of you, this is not factor, this is the opposite of factoring. FOIL, if someone say FOIL, distribute, or FOIL, some of you might have used like a box method or what do you call it, lattice maybe. So when you multiply this, regardless of which method you use, you're ultimately at some point going to have to multiply x times x, and x times x is x squared. You'll also have to multiply x times -5, which gives you a -5x. You'll have to multiply 2 times x, which gives you a 2x, and you'll have to multiply 2 times -5, which gives you a -10. And then we want to simplify that if possible, and you should notice that we do have a couple of like terms. We only have one quadratic term, the x squared term, but the linear terms, -5x and +2x, can be added together, combined together to make -3x. And then the linear term stands alone at the end, giving us our answer. And I want to point out, hopefully you got this drilled in when you were in algebra, but hopefully you remember that the constant, the -10, you got that as a result of multiplying the 2 and the -5 together. You multiply to get that, and you added the -2, or sorry, the 2 and the -5 to get the -3 in the middle. So you multiplied to get the 10, you added to get the -3, and that should be helpful when we come back over to our warm-up problems where we're going the opposite direction. In this case over here that we just did, we had two factors we multiplied out to get a trinomial or a quadratic. Now we're going to go backwards from there. So this first one we're trying to factor. Remember what we just did? We're looking for two numbers that multiply to make 6, that add to make 5. That's a +2 and a +3. It does not matter which one goes first. You have to have an x + 2 and an x + 3, but it could be the other order around. Number 2, same idea. X and x, we need two numbers that multiply to make -24, that add to make -2. +4 and a -6. Once again, doesn't matter which one was first, as long as you get both of those factors. Number 3, hopefully you notice there's only two terms in number 3. It is a quadratic, it is an x squared. The term that's missing is the middle term, the x term, or the linear term. So when I talk about ax squared plus bx plus c, it's the b, the middle term, that we're missing in number 3. So the middle term is the 0. We can think of this as x squared plus 0x minus 25 if you'd like. In which case we're looking for two numbers that multiply to make -25. that when you add them, they make 0. If you add two numbers together and get 0, what must be true about the two numbers? What type of numbers add together to make 0? We call them additive inverses, but it's the same number with opposite signs. So a positive and a negative of the same thing. So we need the same number. And if you multiply the same number by itself, you get a square. And what so happens to be true about 25? It's a perfect square. That would need to be the case here. And so we would have to have a positive 5 and a negative 5. Positive 5 and negative 5 multiplied to make negative 25, and they add to make 0. That particular factoring pattern where the b is a 0 and your last term was a square and it was subtraction is called a difference of squares. Hopefully you remember that one. It's a common factoring problem or pattern that we would use. So just as like an additional practice on that type of problem, take a look at 4q squared minus 81. Is this a difference of two squares? Difference would mean subtraction, so yes, it's subtraction. Is 4q squared a perfect square? Oops, what happened to my 4? There we go, sorry. Got rid of my line. 4q squared is a perfect square and 81 is a perfect square. So it does factor. 4q squared is the square of 2q, so that's what would go first in each set of parentheses. 81 is the square of 9, so you'd have a plus 9 and a minus 9. That's what that would have factored to. It wasn't one of the warm-up problems, but I wanted to throw that in since we just talked about difference of two squares. Then the last problem has a leading coefficient. There's a coefficient in front of x squared. And that's usually the type of problems that cause us the most issue is when we put a number in front. Sometimes, and this is one of those cases, you can factor that out of every term, or another way to think of that is undistribute. You should be good at distributing, but let's undistribute. So if I can divide out a 2 from each of those. So I can put a 2 out front and think about what would happen if I undistribute that. If I pull it out of each term, instead of 2x squared, I'd have x squared. Instead of 2x, I'd have x. And instead of negative 40, I would have negative 20. So work backwards from the distributive property. And technically, that is factored. But our instructions probably would say factor completely. Meaning just because you factor once doesn't necessarily mean you've finished. If you can factor again, you would need to do so. And in this case, I can factor again. I no longer have a lead coefficient on my x squared, so I just have x and x. And I need two numbers that multiply to negative 20 that add to 1. So we get a positive 5 and a negative 4. And there's our factors. So that's our warm-up, but it is also a big piece of what we're doing in this next section. So I'm going to transition formally, I guess, out of warm-up into notes, but it does involve a lot of factoring. Some of our factoring will be more complex than that. You've done a lot of factoring prior to this class, but we will most likely have some factoring in this section that is new. So this is section 4.3. It's titled Solving Quadratic Equations by Factoring. In the last section, the title of the section was Solving Quadratic Equations by graphing. We already solved quadratic equations, but we used a graphing calculator and looked for our x-intercepts. But now instead of using a graphing calculator, we could also think about factoring and using that to solve equations. Each of these problems above, we just factored. We didn't solve any equation. There was no equal sign. So we do go a step beyond in many of these cases because we're actually solving. I'm going to jump in with a type of factoring problem that you probably haven't seen before. And I want to start there. Okay, we're going to factor this 8xy plus 2x minus 12y minus 3. I assume that this might be the first time you have ever been asked to factor something that has 4 terms. Perhaps there's some exceptions to that. Maybe you've seen something else before. But I think in most cases, you probably haven't been asked to factor something with 4 terms. And if that's the case, then you've probably never been taught how to factor by grouping. And so that's what I'm going to teach you. And we're going to factor this by grouping. That's the name of the strategy. What we do when we factor by grouping is we break it into groups, 2 groups. Typically, in all of the grouping problems that we will see, we should be able to just break it in half. So I might actually put a little break in the middle of that problem. And then think about what's in front of that little squiggly line. If I have 8xy plus 2x and I ask you to factor that, I would want to think about everything that they have in common, what I maybe have already distributed that I can undistribute. So I see the coefficients are 8 and 2. I can factor out a 2 from both of those. And variables are x and y, so they both have an x, so I can factor an x out of both. So I put in front what I'm factoring out, 2x, and then in parentheses, what's left after I factor out 2x. So from 8xy, I took away 2x, or I divided out 2x, I'd be left with 4 and y. And then I had positive 2x, and I just factored out 2x. But remember, it's division. 2x divided by 2x is a positive 1. Not a 0. It was division. When we divided the whole thing out, I'm left with 1. Then do the same thing out of the other group. So then I have negative 12y minus 3. I want to see what they have in common, and I don't want a leading coefficient that's negative. And I do have a negative leading coefficient in this case. So not only will I factor out a 3, I'm going to factor out a negative 3. So I don't want the negative to be a part of it. So divide out negative 3 from each of these. So negative 12y divided by negative 3 is positive 4y. And then negative 3 divided by negative 3 is positive 1. I hope you've been able to track with me, but next is where people tend to get lost the most. So before I do the next step, I want us to consider a similar yet different problem that I think is a little bit easier to understand, and then we will kind of work parallel to it as well. So consider the following. Consider 2x times z minus 3 times z. If I asked you to factor this, I hope that you would recognize what they have in common that I can factor out or undistribute. I can pull a z out of both of those terms. So I factor the z out front, and it leaves me then, when I pull away a z from the first term, I'm left with 2x. And when I pull a z from the second term, I'm left with minus 3. Now, It's up to you whether you want to have that written down somewhere or not. That one I hope doesn't lose you. And so I want to tie what we're doing over here in blue into what we just did there. Here's what was different about this one. I gave you a z in both of those cases instead of 4y plus 1. But z represents a number. It's just a variable. It represents a number. What does 4y plus 1 represent? It also represents a number. It's maybe a fancier way, not really fancy, but a more elaborate way of expressing the number because we're putting it in terms of y. But it's just whatever number y is multiplied by 4 and added 1. So it's just a number. It's the same thing as z. I get to do the same steps that I did over on the right. So on the right, I noticed that I had a z in both of them, so I factored it out front. What factor do I have in common over here in this problem? They both have a 4y plus 1. So I get to factor that out. I'm undistributing it. I'm taking it away, pulling it out of both terms. So when I pull the 4y plus 1 out of the first term, what am I left with? Just the 2x. And then when I pull it out of the second term, what happens after the minus? Pull out the 4y plus 1, I undistribute it, I'm left with minus 3. Doesn't that look like it's factored? Factored is when you have two things multiplied together. I turned something that wasn't factored into something that was. So there is our answer, 4y plus 1 times 2x minus 3. That's called factoring by grouping. You'll see a couple of problems like that. And so you'll need to be able to do that. But I also want to tie it into some of the other factoring that you have done before where maybe this will be a good strategy. So now we're going to do a solving problem that looks maybe a little bit more familiar than what that did. Let's solve 16x squared minus 16x plus 3 equals 0. Now this is the first problem I think I've asked about solving. That's the title of the section, is solving. Now we actually get into solving. The section is titled Solving Equations by Factoring. So I'm still going to factor, but then I'll have a step beyond that. Now I want to first point out, when solving by factoring and many other strategies, and it's already done for us in this problem, but you first need to set the equation equal to 0. There's a reason for that, and we'll come back to why that's true, but very important first step. I don't need to worry about it in this problem because everything's already on one side, it's set equal to 0. And now I'm asking us to solve by factoring. So this is unique and harder than the factoring problems that we did in the warm-up. Part of the reason for that is there is a leading coefficient, a 16. The fourth warm-up problem, I gave a leading coefficient of 2, but I was able to factor that out. Remember up above, I pulled a 2 out of every term, and then what was left didn't have a leading coefficient. It was fairly easy to work with. Can I do that in this problem? No, that 3, that pesky 3 there is not divisible by 16, so I can't pull 16 out of everything. There's still, hopefully, going to be 2 sets of parentheses, but because of that 16, it changes the problem. I can't just put x and x in the beginning. because x and x multiply to x squared, and I want a 16x squared. So maybe it's a 4x and a 4x, or maybe it's a 2x and an 8x, or maybe it's an x and it's a 16x. I don't really know. What do I know about the numbers that go last? Well, I know they still have to multiply to a positive 3. There's not a lot of options that multiply to positive 3, so that's good news. Maybe it's a 1 and a 3. Maybe it's 3 and 1. Maybe the order matters. Maybe it's negative 1 and negative 3 because they multiply to a positive as well. So I have a few options, but because we have a leading coefficient, these two numbers will not on their own add together to make the negative 16. It's a different set of rules when I put an a value in there. I don't just multiply to 3 and add to negative 16. Different. So you probably learned a strategy in algebra, and you probably didn't all learn the same strategy. So I'm going to present a method. It's probably a unique way of solving this problem. I'm going to present it to you that relates to what we just did in the problem above it. I know that some of you learned like an x, you created an x when you were factoring. I don't care if you use that x or not, but it is a good tool for what we're going to do right here. And maybe off to the side, let me just put that the rule was in the top of the x, you put whatever a times c was, and in the bottom of the x, you put whatever the b was. And that's a direct connection to ax squared plus bx plus c. So whatever your a is, the coefficient of your x squared, and whatever your c is, you multiply them together, put that in the top, and then whatever b was went in the bottom. So if I do that to this problem, my a is 16, and my c is 3. So I would have to take 16 times 3. Well, that's 48. So that's what goes in the top. And then b, whatever b is, well, b is a negative 16. That's what goes in the bottom. And our goal is to figure out what to put on the left and the right. We need two numbers that multiply together. This is where it feels like the factoring we did above. We need to multiply to make 48 and add to make negative 16. Those are large numbers. Maybe it's not terribly obvious right at the beginning. Hopefully, eventually, you'll realize it's negative 4 and it's negative 12. Negative 4 times negative 12 is positive 48. And when you combine negative 4 and negative 12, you get negative 16. Now, I'm going to come over to the left, and I'm going to actually erase these parentheses because I'm not ready for those yet. The negative 4 and the negative 12, they don't go into the parentheses. I'm going to turn this into a grouping problem, and here's how. The quadratic term I'm going to leave as is. It was a 16x squared. The linear term, the 3, I'm going to leave it as is. But it's the middle term, the linear term, that I'm going to break apart into, and here's where the two numbers I did on the left and right come in play, negative 4x and positive 12x. Oh, sorry, not a positive. It was a negative 12x. So I had a negative 4 and a negative 12, so I put a negative 4x and negative 12x. Don't those together make the negative 16x up here? Yeah, so I just broke it apart differently, and now I'm going to factor by grouping. Look at the left part. I can factor out a 4 and an x. When I pull 4 and x out of the first term, I'm left with a 4 and an x. And when I take the negative 4x and divide it by 4x, I'm left with minus 1. Then the second group, looks like I can pull out a 3. That was a positive 3 there. But the lead coefficient is negative, so I actually want to pull out a negative 3 because I don't want that negative there. So divide out negative 3. Negative 12x divided by negative 3, positive 4x. And 3 divided by negative 3, is -1. Did we get the same thing in both sets of parentheses? Yes, that is very important. If you didn't, then it didn't work, which really means you made a mistake. And so now, because it's the same, just like up above, I can factor that 4x minus 1 out of the problem. Okay. 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 Nope. Yeah, I did not divide the x out. So we have this 4x minus 1 in common. I factor it out front. It goes in the front. And then when I do that, it goes away. I took care of it. So what's left when I pulled that away from each term? Well, the first one was left with 4x. The second term was left with -3. So I have 4x minus 3 that's left after I pull out the 4x minus 1. So there is my factoring. Now, that was the factoring piece. I still haven't solved. Remember, the original problem said equals 0. So I still have this equals 0 there at the end. Oops. Which means I'm not done with the problem. I'm trying to figure out which values of x make this equation true, or another way to say that is I'm trying to find my x-intercepts. This is a problem where would it have been easier to just graph it and find the x-intercept on the graphing calculator? Yeah, probably. Sometimes factoring is easy, sometimes graphing is easier. But we're still going to make sure we understand how to do it. So once you have it factored, we know this number times this number equals 0. The only way that you can get 0 for a product is if one of the numbers is 0. So this is only true if 4x minus 1 is equal to 0, or if 4x minus 3 is equal to 0. This is what we do with factoring when we solve. We take each factor and set each factor individually equal to 0 and solve both of those problems. So I get 1/4. And I get 3/4. There are two numbers that answer this question that when I plugged in for x, they worked. And there they are. Those would have been your x-intercepts if you graphed. As a decimal, to be 0.25 and 0.75. But those are the values of x that make it true. Okay, that's where I'm going to stop the notes. I think that this isn't enough. It's very important that you practice, because if you leave it here, you're probably not practiced up and ready to be successful. And there are a few problems in the assignment that might still confuse you when you take a look at it. But make sure you do some practice. So I highly recommend make sure you do this assignment.